All right, thank you, Nick. Yeah, so my name's Jim, and I'm from Grok, and I'll talk a little bit about Grok later on. I guess there's an audience of teachers and educators here. Who's familiar with Grok and the NCSS challenge? And cool, awesome. So I'll talk a little bit about that. But so embedded programming is a personal interest of mine. Messing around with microcontrollers and Arduinos and things like that, and building circuits and whatever, always has been. For anyone who's taught Arduino or embedded programming in a classroom, you know how difficult this can be. And so this talk is about MicroPython, which is hopefully a great alternative to some of the things that are already out there, and just makes this process so much easier and focuses on the things that are actually important. So MicroPython, first of all, it's Python but micro. It runs on microcontrollers. We'll talk a little bit about what that means. What is a microcontroller? So you're probably familiar with Arduino, which runs on a microcontroller called the 18 Mega. MicroPython is not quite that micro, but it's just a little bit bigger than that. The Cortex M0 is a typical kind of chip that you might run MicroPython on. These are sort of chips that have maybe 1/4 of a megabyte of flash. That's where you store your program and code, and 16K of RAM. So pretty tiny, and they run at sort of 16 megahertz. But it's real Python. It's everything you expect from Python, all of the standard libraries, JSON, sockets, and anyone who's familiar with Python 3 will immediately be familiar with MicroPython. Most of your Python 3 code runs unmodified on the MicroPython runtime. And if you've ever done embedded programming, you're used to doing things like a compile process that then builds an image that you flash on with a programmer and things like that. Once you have a completely set up MicroPython device, you put the MicroPython firmware on there once, and then there's a very easy way of just putting a new main.py onto your thing. So you're dealing just with Python and things that you're already familiar with. And then it's Python 3, but it also gives you Python-style access to all of the things on the device that you'd like to be able to do with a device. Access GPIO pins to turn lights on and off, to control motors, control displays, talk serial, and things like that. MicroPython was created by physicist Damien, who's just walked in the room, and it's going to space. It's being picked up by lots of vendors. It's a really exciting project. It's an easy code base to work on, and functionally has everything you need from Python up to Python 3.4. I should mention the pyboard. If you're looking to bring MicroPython into your classroom, a pyboard is one of the great options. It has an SD card, which is great for additional storage. It's easily extensible, lots of GPIO pins, runs Python, MicroPython out of the box, and it's designed for MicroPython. But one of the main things I actually want to talk about is the BBC MicroBit. When I say BBC MicroBit, this is what people think of. Who went to a school that had a MicroBit? A BBC Micro, I should say. No, we're not talking about this. This is 1981. But what the BBC did is they said, we want to get computing in schools. So we're going to give one of these to every classroom in the UK. And Australia picked up a few as well. What they did this time around is they said, we're going to give one of these, the BBC MicroBit, to every grade 7 student in the UK. That's something like 1 million units that they just shipped. So this is the MicroBit. It's got a little 5x5 LED matrix on the front. So out of the box, you can do things with this. If you've ever used an Arduino and you've been frustrated that all you can do is blink one LED on the Arduino, the MicroBit has 25 LEDs just to start. In addition, it has 2 buttons, an A and a B button. It has an accelerometer, a compass, a temperature sensor, and it talks Bluetooth. And it's built for all of those things. There's no trying to find sample code and things like that. It just works. It's a fully packaged unit that's easy to teach with. And down the bottom, it has a whole bunch of additional pins. The big pins are specifically designed to hook a alligator clip to. So if you want to build a simple circuit, it's really easy just to put a clip on the thing and you're ready to go. There's no breadboarding or anything like that for basic things. As well as the GPIO pins, it'll do standard sort of protocols like SPI, I2C, UART, and 80s, and they're all, a few of them are analog pins as well. It has a battery connector on the top, so you can build battery-powered circuits. This is a big problem with Arduino, if you've ever done big battery packs on your Arduino and things like that. It's incredibly easy to get started with. And they're not that expensive. If you've bought Arduinos for your school, you'll be familiar with just how expensive they can be. You can buy packs of 10 from places like Kitronics in the UK. It works out to roughly $20 to $25 each for the MicroBit. Compare that to some of the options out there. It's worth comparing. It's a more powerful thing than the Arduino Leonardo. It's similar spec to an Arduino Zero. The Explorer, obviously, if you've seen it, has all the buttons and things you can do with it, accelerometers, but Explorers are really expensive and they don't have displays. The Raspberry Pi is actually a whole computer. So when you're teaching with the Raspberry Pi, you have to deal with all the things like running Linux on it and logging into it and software and things like that. And I mentioned the pyboard. Pyboard's another great option for MicroPython. So the BBC worked with a bunch of providers to build this board. They're basically, we're just going to make this happen. And all these individual providers came together to actually produce the board. So Nordic supplied the CPU. Microsoft was a big partner, and they provided ultimately some of the programming tools for it. And one of the really cool things the BBC did was said, all of this is going to happen in the browser, whether it's coding or block or visual programming. You build up your program in the website. We provide free access to that. And the thing you get from that is an image that you can just drag onto the MicroBit. So if you've done Arduino, again, so I actually really like Arduino, so I don't want to keep hating on it, but the process for the MicroBit is just so much simpler. You download a .hex file, the MicroBit shows up as a USB drive on your computer, you drag that downloaded file onto it, and it reboots, and you have your code running on it immediately. But what the BBC did was the 4 options they provide for languages, the 4th one is MicroPython. And you go to the website, you get a little IDE in the browser, and you write Python in the browser. And now an ecosystem is popping up, just like Arduino, which is wonderful. A company called Kitronic in the UK is doing things like motorized buggies, motors, lights, NeoPixels, the whole works. And it's easy just to connect the pins. One thing that's worth mentioning, and the reason I put another picture up here, is that these pins are a little bit annoying other than the alligator clip ones. So a must-have accessory is the edge connector, and it's basically a little slot that it goes in and exposes all these pins on a breadboard compatible board. So some more info, the MicroPython documentation, the MicroBit website itself. The third link is interesting. The MicroBit is an ARM-based development platform. If you have really advanced students who actually want to break free of the provided sort of sandbox and things like that and treat this as a professional thing that like a real software engineer or a real hardware engineer would work on, you can download all the ARM-based tools that use the embed platform and build C++ code from scratch. Like this is a board that actually is quite limitless in terms of your options and things to learn from it. And then Kitronic are one of the providers of accessories and so forth for the MicroBit. All right, so now it's time for the obligatory demo. So I have another MicroBit plugged in here. This is the maze demo, and so if you can see, there's a flashing light in the center. That's where I am, and the red lights are the walls. And what I can do, it's a bit hard to see because I have to do this, but I can move using the accelerometer to move around the maze. Surprisingly difficult. I've actually yet to succeed at more than about once. But the great thing about this, and this is true of many MicroPython boards, is that I can connect to this as a terminal. So at the moment my code's running, so I just see nothing on the terminal. But just like a regular Python program, I can hit Control-C, and here I am at the Python prompt. And this is the exciting part about the MicroPython, something you just can't even imagine doing on an Arduino, is that I can run Python code on this board. So you can see my little maze demo has stopped. Sorry. There we go. And I can turn pins on. I can turn. I can turn pins on. I can do all the things I can do with programs, or I can even paste like snippets of code into this. So this is a really, really important thing for getting electronics working in the classroom, because so much of your time is spent going through this iteration cycle of trying to figure out what works and what do I need to set the pin high or low or whatever. Now you can just interact with it. It's the equivalent of the Python REPL loop. This is really, really, really powerful. There's a sort of a standard demo I have to do for the MicroBit. One of the things about it is that you can plug a speaker into it, of course, because there are pins and if I alligator clip them onto there. Input music. So MicroPython provides a bunch of libraries, and then depending on the board, you get libraries specific to that board. So we have a music library for the MicroBit. Player sound, not very exciting. But what I should do is get the sound from somewhere else. So this is like the demo you have to do. That's not working. I've done that wrong. Probably it needs to be in a loop, of course. Thank you. Live demo. Why would anyone live demo anything? Press enter again. You get the idea. You probably can't even hear that from the back, but yeah. Oh, hold on. I have a microphone. Cool. How good is that? All right, that's demo 1 of 4. Let's see how the rest go. Okay, so that's the MicroBit. This is a great option for teaching embedded programming in classrooms. There's a lot you can do with this. I made a really fun Tetris game where all the blocks are one LED. It's really easy, but it was a fun way to learn about arrays and moving things around. The next thing, and this has been talked about a lot already today, is the ESP8266. So this is an ESP8266. It costs $5. It runs MicroPython and it has a Wi-Fi chip in it. And it can be an access point or a station. Most of this board is the antenna at the bottom. Let's get another photo. The antenna at the bottom and the giant pin header on the top. The actual interesting part is these 2 chips in the middle. One's a flash chip and one's the actual Wi-Fi and system on chip processor. It runs MicroPython at 80 megahertz. It is actually a seriously powerful little bit of computing. And you can get various modules, variants of this that have a whole lot of GPIO. So you can build Internet of Things, wirelessly connected, classroom-based activities, whatever, for $5. It's quite amazing what you can do. It's tiny and cheap. You configure it once, you put MicroPython on it, and then what happens is it becomes a thing on the network, and you can connect to it over Wi-Fi, and you upload code, run that same interactive Python prompt that we just showed you, and it has a whole lot of library support for everything you'd ever want to do. NeoPixels, all the things we talked about earlier, JSON, whatever. And it can be an access point. And being an access point means you don't have to worry about whether or not your school has Wi-Fi or the Wi-Fi works or it's available or things like that. You connect to it instead. Just as a quick sort of warning, if you're going to go and pursue the ESP8266, it's a really confusing thing to build for. There's like, once you get the one you want and the one that works, then you just go with that, but figuring that out can be a little bit tricky. There was another talk earlier today in the Internet of Things conference about this, and then there was the keynote this morning in the Internet of Things about the history here. It's a kind of a weird thing. It was built for a purpose, and then people discovered it, and suddenly were like, wow, this is a cheap Wi-Fi chip, let's do things with it. But it involved a lot of reverse engineering, some very, very clever people who built the open source version of the SDKs that MicroPython is built on. This is called the ESP01 board, this form factor you saw earlier, but there are like 14 different variants of this board, and I'll give you some recommendations a bit later on. If you are going to do MicroPython on this, make sure you get at least an 8 megabit one. Watch out for megabit versus megabyte. So 8 megabit is 1 megabyte. You need enough flash to run MicroPython. This board on its own is painful. I had to make a programmer from scratch, this sort of thing. Get one that has a programmer built in, or buy a specific programmer for the purpose. But once they're programmed, they just run Python, and then they're on the Wi-Fi. So then once you've got it all set up, you just need to do that once, and then it's quite easy to work with. This one only has 2 GPIO pins, so it's not very easy to plug into other devices, but the other editions have like 22 GPIO pins. One thing to watch out for, you have to build your own MicroPython code the first time. I'm sure that will change soon. MicroPython on the ESP8266 was a Kickstarter, and originally the binary images were only available to backers, but I imagine that will change at some point. But I just have to warn you, if you're going to use this in the classroom, ESP8266 is run at 3.3 volts, not the sort of 5 volt that you're used to for Arduinos. So if you're going to mix and match it with other things and other devices, be aware of this. This is summarized basically as buy a board that does this all completely for you. A great example is the Adafruit Feather Huzzah board, and it has, as you can see, the ESP module is this thing there, and then a bunch of other USB interfaces and voltage conversions and things like that. This is a great board to use to build Wi-Fi projects in the classroom. SparkFun, I have another one called the IoT Thing. If you want to learn more about this, there's a great talk about the history of the ESP8266 from LCA earlier this year by Angus Grattan, and then 2 talks from the PyCon conference that we're currently at earlier today. Okay, this demo I'll do very, very quickly. So this is a ESP8266 connected to a little LED matrix. And the point here is that once I've powered it up, and I could be powering this by a battery, but I'm just using this handy little 3.3 supply here. That's what I'm doing. So this thing boots up and provides an access point. And if I switch my laptop's Wi-Fi over to, where are we? Yeah, it's got a password on it though, so I don't want to spend too much time on this. I might demo this afterwards because it might take a bit of time. But basically, it provides a wireless access point. You connect to it. It serves up a web page. And that web page is a picture of this grid, and you can turn the pixels on and off, and multiple people can interact with it, things like that. The point that I actually wanted to make here is that it's about this much HTML to make the little grid on the web page and the JavaScript and whatever, and about this much MicroPython to actually control the LEDs and do the web server and things like that. And if you've ever done sort of any network-based stuff on an embedded device and dealing with string processing, whatever, it's painful. Whereas Python are just string.starts with and split and things like that. It's really, really easy, and the cool thing is you get to focus on the actual concepts that are important to you, not the dealing with difficult embedded systems things. Okay, next up. So I'm from Grok Learning, Australian company providing online courses, specifically Python, the NCSS challenge and things like that. We're really excited about embedded programming as a future direction, and the MicroBit in particular that we demoed earlier. So when you're running embedded stuff in a classroom, the big problem we have is that devices are flaky, wires fall out. There's a lot of other things you have to do other than just writing code. So it actually is very hard to teach the core concepts around coding when you have to deal with everything else, programming and flashing and devices that fail and things like that. So Grok provides interactive notes and automatically assessing submissions for Python. So I'll give a quick background on Grok. Learn to code from your browser. This is beginner's course. Skip registration. So notes on the left-hand side, and then an interactive Python thing with a marker and an interactive Python shell here. So our goal was to provide exactly that experience for the MicroBit. So we're building a course that when you that means you don't have to have that speaker's still buzzing. So we provide notes about how the MicroBit works, and there's a little code snippet, and then you can click run, and we'll actually run a MicroBit in your browser. And it's a real MicroBit. It's not Python pretending to be a MicroBit. It's actually the same software, the MicroPython runtime and so forth. And for example, one of the concepts you learn very on in embedded programming is dealing with loops and buttons. And buttons are hard because you've got to deal with the fact that they might sort of jitter a little bit and they might hold them down and stuff like that. So here's an example of sort of 4 slides where we work through the concept of how to deal with pressing a button that ultimately finishes in an exercise, which is write a program to do a specific thing. And so if I run this program, not a great resolution, and I can press the button and button A, and I interact with my device. And then for an assessment, I can actually mark this. Did the program actually do what it was supposed to do? And when I run it, it will run that code on a real device and measure things about the timing and about whether the inputs did the right thing. So you can build content and courses around this that emphasize the actual fundamentals of writing code, not about did you build this project that kind of worked in the end, but actually did you write this code correctly and did it behave exactly as we wanted it to. We're extending this with, so that demo I gave you earlier of the speaker and the accelerometer. So this is an example where we use the compass and we can point to where north is while the code's running. The maze demo that I was trying to show you on the real device can run on the device in the browser as well. And so as I navigate around, you can see that was what I was trying to show you on the real MicroBit. But more importantly, students want to build things that are actually connected to other devices. So we have lights and servo motors. The speaker demo from earlier, you can press a button and get it. You probably can't hear my speakers, but there's playing a tone. And most importantly, sorry, let me stop that first. Most importantly, when I press the button, this is as if you had a policeman. So what we've done is we've configured this workspace to say, pretend they plugged a speaker into pin 0. And all right. Fortunately, there's a power button as well. Plug in external devices like RGB LEDs, configure the brightness of those LEDs based on the orientation of the device and things like that. So, and not worry about whether or not the LEDs are plugged in correctly. That's a big thing. Servo motors, what we'd eventually like to do is actually completely emulate the robotic buggy, the Kitronic kit that we saw earlier. So in this case, what we have is when I press the buttons, it turns the servo to the appropriate place. But it's the same. It's the Python code that you would have written, and this is kind of a great opportunity to show you what MicroPython is like. That I can just read from the pins and write to the pins. And so there's actually a servo library that I'm not using this example, but I'm setting the servo orientation just by writing to a pin from Python. If this was Arduino, I'd have to set the pin modes and all those sort of things and whatever. Just run the whole thing in a loop with a sleep at the bottom, and that's the whole program. Yeah, and all of those components can be integrated with the marker and so forth. So yeah, we're looking forward to rolling this out as a Grok Learning course. If you're interested, the Grok Code Quest starts in October, the end of October this year, and we'll be including a MicroBit stream based on the things. Additionally, students really like to, especially younger students, find programming difficult when you have to do a lot of typing and things like that. So we've also built a Blockly-based interface for the MicroPython. So as you drag your blocks around, it generates the MicroPython code for you, and then you can run it in the same interactive thing. Just some background on the development of this. It was really important to us that this felt like a real MicroBit. It should run out of memory in the same way that a MicroBit runs out of memory, because it's a tiny little device. You shouldn't be able to just run regular Python code, because you can't run regular Python code like random stuff from the internet. Which is why we actually run the MicroPython MicroBit firmware rather than just emulating this in Python. If anyone's interested in the technology behind how we do that, I'd love to talk about that in more detail later on. Come and find me over here all weekend. That's about it. Questions? I'm really interested in teaching embedded programming in schools. I think MicroPython is one of the best things you have available to do this. I would love, if you have ideas what you do in school, tell us what your school does. I'd just love to know about it. My email address is at the bottom of this slide. And if you'd like to know more about any of the things in this slide, email me. I'd love to talk about it. So, yeah, thank you.
Anyone have questions for Jim?
Thanks. I'm similarly really interested in embedded programming as a method for teaching, I guess, computer science and programming. One of the things with MicroPython I found really lacking is that there's no sort of debugger. You kind of either can be running the code or you can be in the REPL, but as soon as you're trying to break into the code that you've pre-written, it's really hard, and I'm sort of really big on teaching debugging. to students. Is there any, I guess, movement going towards even a really simple debugger in MicroPython?
I would probably imagine that Damien would have a lot more to say about this. From a technical perspective, a debugger is actually quite a difficult thing to provide on a device that small. Arduino has a similar limitation. It's something like a Leonardo, you can actually put a JTAG debugger on. One thing I have noticed, the transition from doing sort of Arduino stuff to MicroPython stuff, adding print statements suddenly is a lot more useful, because while you're still on that shell, the print statements come through and things like that. So standard sort of techniques for tracing and annotating your code are a lot easier on MicroPython than they have been on other devices. Just really simple things. Having 25 LEDs on the device makes it really easy to indicate, I'm in this part of the code or things like that. But yeah, an interactive step-by-step source code level debugger would be wonderful. Yeah.
I have a question.
Yeah.
If people actually wanted to get their hands on a microbit,
Yeah.
how would they do that?
The link I provided earlier, Kitronic, are providing international distribution for the microbit. They're roughly 25 Australian dollars. Yeah, you've got yours. Yeah, so it does work. You can buy them. Yeah.
Thanks for the talk. It was really cool. Can the web thing talk to its hardware? And have you thought about trying to do that? Like, so instead of running a virtualized microbit, talking to a microbit?
Talking to run with a real microbit.
Right. So plug it in by USB or something. And
So what we provide is a download button, the same as the way the BBC website works. So if you have a real microbit, pressing that button will then give you the thing that you can drag onto your real microbit. Yeah, it would be a step where we didn't have to have that download and drag and drop thing would be really great. But yeah, at this stage, that's the limitation. Yeah.
Then you get into browser access to USB ports, which is exciting.
Yeah, and just generally USB.
Any other questions? Okay, in that case, please say
Wonderful.
thank you to Jim.
Thank you so much.